Hi viewers, welcome to LMS Solution. Today we are going to see about fault detection and classification and also fault location finding by using neural network. This is the model is developed for fault detection, location, classification by neural network in the 3 bus system. They have 3 buses, bus 1 and 2 and then 3. Bus 1 and 2 going to act as your source first and then 3 going back as a load bus, and then in between bus 1 and 3 we have the transmission line. Here we are using the 10 kilometer line, and then in between these two transmission line we are creating fault here. And also here we are measuring that the bus 1 voltage and current in the form of RMS, and also we are measuring the series sequence current and voltage of the bus 1 in order to detect the fault and classify the fault and find the fault location during fault. In order to do this one, we have that code. This is a code used for collecting the data during fault condition. We can create line to ground fault, double end ground fault, double end fault, triple end fault. We need to create that fault in the system. For that we have different model. Here you can see that this is a model for creating the line to ground fault. That means AG fault. That means the fault created between line A and B. Here you can see that line A and B. This model used for creating a fault between line A and B, and then we are collecting the data. Same way we are having a different model for different faults. Here you can see that here we are created fault. Here we are going to execute this model with the different line length. Here we are execute the model first with line length of 10, and then we are executing model with the line length of 5, and then we are executing model with line length of 1. So we are executing the model with the different line length. That means we are creating fault at the different location. So here we are creating fault at 10 kilometer, 5 kilometer and 1 kilometer. Just you have to use this only for fault occur in the 10th kilometer. What is the data for the different fault details? Here we are going to collect the data VA, BB, VC, IA, IB, AC, and then this will be considered input data for different cases. This is for normal case and this is for fault case. And then here we are collecting the data, and then here they have 5 numbers, and when 5 bits you can consider 5 numbers. The first 4 will be used for detection of fault and the classification of fault. The last one used for finding the location of the fault. And each fault having the different binary number, 4-bit binary number. For example, you consider normal case. We are having the binary number which is equal to 0, 0, 0. Now you can consider that you consider fault between A and G. Then the binary number we are having 1, 0, 0, 1. Here we are fixing the target value for the different fault. That means here we are changing the binary pattern for the different faults. And also if suppose you are fixing line length equal to 10, that means fault location, then we are making that on the 5th data will be equal to the target data which is equal to 10 according to the length of the fault. This program used for collect the data. Here you can see that we are collect the data already. If you run this code, it will execute that model, execute all different normal model and then fault condition for the different fault like AG, PG, CG and EB, AC, VC. Different fault will be executed, and then you can collect the data here. This will be appear up here that like in X data. Finally you have X data and D data. This is X data and then we have D data. By using this data, X data and D data, we need to train the neural network. X data nothing but the RMS voltage and current of the bus 1, and then zero sequence voltage and current of the bus 1. The D data nothing but the target data for the normal and the fault condition, and also here in D data we are fixing the location. So now we can see that this is the target data we are generated, and then this is location data we are generated for the different fault, and then here this is data collected input data for bus 1 voltage and current, and then zero sequence voltage and current. By using this input and target data, we are going to train the neural network. For that you go for a neural fitting tool and then go to next and then click the X data and then here you can use anti data, and then click matrix rows, and then click next, and click next, and click next, and then train the neural network. Just you got to train the neural network. After training, you can see the R value. The R value is 0 to 1. Here the R value is 0.97, 0.92 is 0 to 1. Then what's the meaning that our the trained neural network is matched with our collected input at a target data. That is the matching. We can click the plot regression and see the match between our input at our that collected data and trained data. Here you can see that R value is almost 0.9798 and 0.99, 0.98, almost equal to 1. What's the meaning here? That the data, trained neural network having matched with that our collected input and target data. That is the meaning. So next you got to click next button, and then you can click Simulink diagram, because we are going to use this neural network and the Simulink diagram to detect the fault, detect the location, and then classify the fault. So just to go to click this one, and then you can use this model in the Simulink diagram for detecting the fault and classify the fault and find the location of the fault. Already we developed that one, and then here it is having this one. Here we have that in detail. That means this is used for detect and classify and find the location of the neural network. This one known as used for detecting the fault. That means further you have to execute this program. This one here we are target only 0. So 0 means there is no fault in the system, and then 1 means that means fault occur in the system. The neural network output having only one output, but classification it having 5 outputs. The first 4 will be used for detection and classification of fault. The last one is used for finding the location. For detection model, this model you have to use this program and then collect the data. After then you go to train the data by using a data concept. Now I'm going to create the fault. Here I create the fault AB ground fault, and then here we have fixed line in 4 and 6. Total length will be 10 kilometers, because we consider only 10 kilometer line. The output of this neural network, this output detection model is going to be compared with more than 0.5, 0.1. If more than 0.1 means the fault is detected in the system, less than 0.1 means the fault is not detected, fault is not present in the system. And also here we have neural network. This neural network used for classification and detection also. It provide 5 output. The first 4 will be used for classification, that will be compared with 0.5. That means we are converting the output of neural network in the binary form. That's why here we are comparing. After converting this 0.5, we have decoder. So this is a decoder. The decoder used for decoding the 4-bit logic into the classification. For that we got this decoding logic by using AND and OR logic. Finally, you can see that fault detection and classification in the scope. And here you can see that the fault location, exact location. Here we mentioned the fault will be AB ground fault, and then here we are fixing that kilometer will be 4 and 6. Now I'm going to simulate this model and then check the result. Here you can see that fault is detected. That's why it changed from 0 to 1. 0 means no fault, 1 means fault. And also you can check the remaining detail. Here you can see that AB ground fault will be changed from 0 to 1. The fault is classified as ABG ground fault. And here you can see that the fault location we are getting around 3.8 kilometer, but fault is occurred to 4 kilometer, is nearer to that 4 kilometer, 3.8 kilometer. Now I'm going to change the fault location 6, here 6 and here 4. We will see that same fault condition. What's the result? We got to check that one. Now you can see that again the fault is detected from 0 to 1, and then ABG fault detected from 0 to 1, and the location where here we are having 5.76, because here fault will be located at 6 kilometer. So we are getting 5.76. And I'm going to change to line length equal to 9, and then here I'm going to make 1, and then I'm going to again execute this model and check the classification, detection and the fault finding location. Here you can see that here also for this condition also we are detecting the fault detector will change from 0 to 1, and then here you can see that here you can the fault classification change from 0 to 1. We have to classify the fault as ABG fault, and then we are getting location is the 8.8 kilometer, but actual location is 9 kilometer we are providing. the value is nearer to 9 km. Next, I'm going to change the fault to B to ground fault, right? And then I'm going to check the results. Now you can see that the B to ground fault is classified, and then we are getting the fault location around 9.091 kilometer. For this fault condition also, we are detecting the fault effectively and classifying the fault effectively, and then finding the location of the fault effectively in the system. So this is the working of the fault detection, location, classification by neural network in the 3-bus system. Thanks for watching our videos. So kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.